Smart contracts, the future of digital agreements. Hey there, crypto enthusiasts. Welcome back to BitSpools, where we dissect the digital world, one block at a time. Today, we're diving deep into the heart of blockchain tech, smart contracts. Now picture this, a world where agreements enforce themselves. No more red tape, no more middlemen. That's the promise of smart contracts. In this digital revolution, they're the big guns changing the game. So what are these magical contracts? They're basically agreements written in code, running on autopilot. They execute the terms of the contract when specific conditions are met, all without human intervention. Think of them as digital robots for your deals. Smart contracts are the backbone of decentralized applications, also known as dApps. They make these apps work without a boss, keeping things fair, transparent, and secure. And guess what? If you're a developer, mastering smart contracts opens up a world of possibilities across tons of industries. Now, if you're ready to dive into the world of building these digital contracts, I'm your guide. But first things first, let's talk about your tools, the development environments. Truffle, it's like a Swiss Army knife for smart contract development. It's got all the tools you need, creating, compiling, linking, deploying, the whole shebang. Truffle makes your life easier with its fancy features. Hardhat, developers love this one because it's flexible and customizable. Think of it as a powerful engine with a bunch of extra bells and whistles. Ganache, this one's like your own personal blockchain for Ethereum developers. It's your sandbox to play around in, test your contracts, build your apps, all in a safe and controlled environment. Alright, tools in hand, let's set up your development environment. 1. Install Node.js and npm, those are your basic building blocks. 2. Install Truffle, type npm install gtruffle in your terminal. 3. Install Hardhat, type npm install save dev Hardhat in your terminal. 4. Install Ganache. You can find instructions on their website. Now let's get testing, because you wouldn't build a house without testing the foundation, would you? For testing your smart contracts in JavaScript, you need Mocha and Chai. Mocha's the test framework, Chai's the assertion library. They work together to run your tests and check if everything's as expected. But hey, we're not testing in the real world, right? That's why you have Ganache, your personal blockchain playground. You can deploy your contracts there and test them in a safe space. But hold on, testing isn't just about throwing code at the wall and seeing what sticks. You need to follow these best practices. 1. Write comprehensive test cases, don't leave any stone unturned. Test every single part of your contract to catch any hidden bugs. 2. Use assertions, make sure your contract behaves exactly as planned. Use Chai to write assertions and validate everything is working correctly. 3. Mock external dependencies. Pretend your contract interacts with other contracts or services. This isolates the contract you're testing and lets you focus on its core functionality. 4. Automate tests. Don't waste time manually running tests. Set up automated tests to streamline the process and quickly identify any issues. 5. Optimize gas usage. Gas is like the fuel for your smart contracts. Test and optimize your contract's gas consumption to make it efficient and cost-effective. 6. Perform security testing. Security is paramount. Conduct thorough security tests to find and fix any vulnerabilities before deploying your contract to the real world. 7. Maintain a test suite. Keep your tests organized and up to date. This makes it easier to maintain and update your contract in the future. 8. Test network deployment. Before deploying your contract to the main network, make sure it works flawlessly on a test network. Example usage. JavaScript. Const expect equal to required Chai. Describe simple storage contract function. It deployment should assign the initial value. Async function. Const owner equal to await ethers. Get signers. Const simple storage equal to await ethers. Contract factory simple storage. Const simple storage equal to await simple storage. Deploy. Await simple storage. Deployed. Expect await simple storage. To equal 0. It should store the correct value. Async function. Const owner equal to await ethers. Deploy. Await simple storage. Deployed. Const set value equal to await simple storage. Set 2. Await set value. Wait. Expect await simple storage. Equal. Now let's talk about building these smart contracts. We'll go through the lifecycle from design to deployment. The smart contract lifecycle. 1. Design. This is where you outline the purpose, requirements, and key metrics of your contract. What's it supposed to do? How will it work? 2. Development, time to code. Here's where you turn your blueprint into reality, writing the code that brings your smart contract to life. 3. Testing, don't forget to test. This is where you make sure your code is free of errors and behaves as you intended. 4. Deployment, once you're confident your code is solid, you can deploy your contract to the blockchain. This makes it live and accessible to anyone. 5. Maintenance, even after deployment, you need to keep an eye on your contract. Monitor it for any issues and make updates as needed. Writing smart contracts. Here's a basic smart contract template. Solidity. Pragma Solidity 0.8.0. Contract simple storage. UN256 private stored data. Function set UN256x public. Stored data equal to x. Function get. Public view returns uint. Return stored data. This code has 3 key parts: state variables, functions, and events. Functions define the actions your contract can perform, and state variables store the data. Common patterns and practices. Now, let's talk about some common patterns you'll encounter. 1. Factory pattern. This pattern lets you create multiple instances of a contract quickly and efficiently. Think of it as a contract factory, churning out new contracts on demand. This is useful if you need to deploy different versions of your contract for different users or scenarios. 2. Singleton pattern. This pattern ensures that only one instance of your contract exists and makes it accessible globally. It's great for contracts that manage global state or resources, like a central registry or a governing contract. Here are some best practices for writing clean and efficient contracts. 1. Keep it simple, don't overcomplicate things. Make your contracts easy to understand and maintain. 2. Descriptive naming. Use clear and descriptive names for your variables and functions. This makes your code easier to read and understand. 3. Follow coding standards. Stick to the established coding standards for solidity. This ensures your code is consistent and maintainable. 4. Optimize gas usage. Gas is your contract's fuel. Optimize its consumption for efficiency and cost savings. 5. Implement access control. Control who can interact with your contract and how. This is essential for security. 6. Conduct regular audits. Don't take security for granted. Regularly audit your contracts to catch any vulnerabilities before they cause trouble. 7. Maintain proper documentation. Document your code well. This helps you and others understand how your contract works and makes maintenance easier. Interacting with smart contracts. Now, let's get your front end talking to your smart contract. For this, you'll use libraries like web3.py and ethers.js. Web3.py.